Hi, everyone. Ready to start? Okay. So we'll try to be on time as we are the first workshop of the exhibit. So we are really pleased to be with you today with Alexandre. Today we'll talk about topics that are really at trend, I would say, robotics and AI, and we'll try to apply that to civil engineering and specifically inspection. First, we'll introduce yourself. So Alexandre, if you can introduce yourself.
Good morning, everyone. I'm Alexandre Havard. I'm the Director of Major Projects at Socotec Power Services, and I'm an engineer in nuclear safety.
And my name is Raphaël Leclerc, so I have two main hats. First one being a Group Head of Data and AI at Socotec, and second being AI Professor at École Normale Supérieure Paris-Saclay, where I try to apply machine learning techniques to civil engineering. So today I'm really happy because this is what we are going to talk about. So the agenda for today, we'll start, of course, with a bit of context. Always good to start with that. A few words about Socotec because I'm not sure everybody knows the company, specifically in the nuclear sector. Second one about, of course, the nuclear infrastructure context, which is quite specific. And then we'll focus on two use cases. First one being SOFIA, how to augment our inspector on site. And the second being, of course, this robot that is on stage for purpose about radioactivity survey. And then we'll finish with how this data is used in order to plan your maintenance correctly.
So Socotec is a global group, about 13,000 employees worldwide, a little bit less than half in France, the rest abroad. The global turnover is around 1.5 billion euros yearly. We operate in 27 countries, mainly France, the US, and in Europe, the UK, Netherlands, Germany, Italy, and Spain. In France, we have a very discrete, not discrete, but a very fine approach on the territory with almost 200 local branches addressing client needs. Socotec is divided in business units addressing each specific issues. Construction and real estate being the historical one. Infrastructure being one of the main areas of development today. Infrastructures encompasses bridges, dams, underground facilities, and it's at the frontier with equipment and industry where we house our nuclear and oil and gas capabilities, for instance. In those fields, we are specialized in the monitoring and assessment of civil engineering, as well as the critical equipment of the facilities. In the environment business unit, we are more focused on monitoring the environment at large around industrial sites, as well as working on worker safeties at their working stations. And finally, we have a focus on training and certification with training centers all across France, both in the nuclear industries and in the general industries, training workers to work at height, to operate lifts, as well as working in nuclear conditions where we mimic, for instance, radiation protection equipment and radioactive environment. In the nuclear industry specifically, we are built on two pillars. The first one being the coordination, the supervision, and inspection, as well as studies. So we have teams on the ground at the nuclear power plants, at the nuclear recycling plants, working with the operators and doing the supervision of the civil engineering works that are happening there, as well as the supervision of the deployment of process equipment or support equipment. We do expert assessment of existing buildings, but also of future buildings. We do study review, third-party review. We do technical monitoring, so that means we can monitor the civil engineering as it's being built, as well as the equipment, how they are being deployed. And we also do cross calculations, not as a designer, but always as a third party. That may have been the first thing I needed to say about the Socotec group, is that we are a third party in everything we do. And what we provide to our clients is basically trust in their projects and in their supply chain. The second pillar of what we do in the nuclear field and on what we are going to delve into today is inspections. That can be regulatory inspections, that can be inspection on the workshop, and that can be mainly inspection of infrastructures in the field. The main tool we have is visual inspection. Of civil engineering, verification of the conditions of the building, of the equipment. We help our client to develop their maintenance plan as well and their inspection plans. We do non-destructive testings. Pretty much any technique that will come to your mind, we have in-house with the capability to do the testings ourselves. We have two radiography, industrial radiography bunkers, one in Cherbourg, in Cherbourg, where we can do radiographic testings in-house of your equipment. We can also do it on premises. And we do regulatory inspections. That goes from small lifting equipment to the polar cranes of a nuclear power plant. That means roughly 600 nuclear experts across the globe, 400 of them in France, with a turnover of roughly 50 million euros, 3/4 of them in France. So the inspection services for the nuclear industry, so as I said, it's split in those three sectors. So the first one, the inspection of critical infrastructures. We rely mainly on visual inspection. So the main tool we have is the eyes and the training of our workers. They are trained to recognize defects in the civil structure, in the equipment as they are being deployed. We do a little bit of ground penetration and packometry, but that comes as a support to the visual inspection, the main tool being the visual inspection. In that field, for instance, we provide visual inspection for half of EDF's NPPs in France. We have a team of 40 to 50 inspectors on site, checking basically that the civil engineering part of the plant is still playing its role. In the areas of inspection of process and support equipment, we rely a lot on non-destructive methods. So I've put here the list of, so we do radiographic testing, leak testing, ultrasounds, magnetoscopic and visual testings as well. We do quality assurance and quality control on the workshop as well as in the plant where the equipment are going to be installed and operated. And finally, we do the regulatory inspection of machines and equipment. All of these inspection services is basically 4 million euros supervising infrastructures and 1.5 supervising equipment, or inspecting equipment.
So, yeah, it's a major business for Socotec, and just to also give you a bit of vision about how the use cases will develop later sit into our global AI strategy. Just a few words about ChatGPT. Of course, when we talk about AI, of course, there is a before and after ChatGPT for sure. I've been working on AI before ChatGPT, but of course there was a huge acceleration on the effort that we put into developing AI systems at Socotec. 2 years ago, we decided, of course, to accelerate, and we launched a dedicated AI and data and AI hub. The idea is the following. We wanted, of course, as we are a multinational country, we are based in 27 countries. We are more or less the same activities on the different geographies. The idea was really to bring collective intelligence in the scene, and also to being able to leverage our focus. Because what's described, I would say, Socotec at best, yes, we're a third party, but we are a third party that is focusing only on the building and infrastructure world, which means that we've got, and you'll see that in the use case later, we've got tons of data that are really high-value data. And of course, as we have the same activities across the globe, we can scale and reuse the technology on our different countries. We defined 5 strategic pillars. So of course, I won't elaborate all of them today, but what is interesting on this session, we'll focus on the first 2, being how can we enhance inspection, augment inspection with AI, and the second, how can we have automation with robotics?
So the key drivers and challenges of the inspection business in general are here. The first one is the lifetime extension of unique assets. So the picture here is the Tricastin power plant in France, one of the first one being built almost 50 years ago. And in the back is the first enrichment plant in France. Lifetime extension of those assets is critical today. Because when they were built, we didn't know how long they were going to last. French regulation says that a nuclear asset is authorized to operate for 10 years. And after 10 years, we need to check that it's, again, authorized to operate for another 10 years. Now we are looking to operate this power plant maybe until 60 years, maybe 70, maybe 80. That brings us a lot further in the future. And that means that we need to be sure today that the civil engineering that can't be replaced is still in shape to perform its safety functions. And that's where inspection comes in. Some equipment can be replaced, but again, those major equipment, the replacement needs to be anticipated a lot. And the later it is, the cheaper it can be, and that's also one of the drivers. When we talk of constructing new facilities, we don't build a nuclear power plant today as we did 50 or 60 years back. They are built with longer planned life cycle in mind, but that means that there are a lot more requirements on the working site as well to be sure that they are built as they were designed, and that during the construction of the power plants themselves, they need to be monitored and supervised. And so all the new challenges. The safety demonstration requires a robust audit trail. That's been true for many decades now. But the more data we generate, the more complex it becomes to analyze, and the more we need to ask ourselves what actually needs to be captured. The digitalization of those complex assets has also been a challenge. It's becoming an old challenge, but it's still a challenge in some places because at that Tricastin power plant, it wasn't built with a 3D model. Everything had to be reverse engineered to get into a digital maintenance plan to then be able to use digital inspection tools. Recruitment and retention of key resources. I think we all have that same issue in the nuclear field, but in any industrial field, actually. And there is a big question as to how to pass down the knowledge and how to train new workers as well. And finally, we won't talk about it today, but there is an issue about cybersecurity and how to address it in this digitization of the nuclear industry. And the big question that we always have, how mature does a solution need to be implemented in the nuclear environment? If some of you are from other industries, maybe what we'll show to you today, you'll say, we developed that 10 years ago. It's not news, but in the nuclear field, it's news. What Raphael is going to present to you a bit later about SOFIA, in the infrastructure business, it's yesterday's news. In the nuclear field, it's a few years down the line. So the preventive, so I'm going to present to you the preventive maintenance value chain, show to you where Socotec fits, and then it will be a bit more clear where we talk of AI. So we have an operator that has their asset. They want nuclear safety, and they have requirements they need to fulfill, and they need their asset to be operational because at the end of the day, they want to produce electricity, they want to reprocess waste, but they have to have a plant that is doing something. And they now have the issue or the challenge of long-term operation and they have their systemic maintenance plan. In collaboration with the suppliers, they develop a maintenance plan. I'd say that was the old way. These equipment need to be checked every 5 years, this one every 10 years. That drain needs to be checked every half a year. And they call for specialized suppliers to do the condition assessment of their asset. So that's mainly visual inspection. It can be non-destructive testings, and in some cases, destructive testing. But of course, that's the one that's, I'd say, the rarest, because once you've done a destructive test, you need to repair. When the condition assessment has been made, then a risk analysis has to be done, a technical economic analysis, and that leads to actions. It can be repair, further studies, and so on. That's where Socotec, we don't play any part. We don't act on what we assess. We only assess. Once a condition assessment is robust enough and has been made, it enables the operator to shift its focus a little bit and to go to a condition-based maintenance. Defects were discovered, so the next round of the maintenance plan is going to be a bit more focused on other areas. And EDF, for instance, has a nationwide fleet. If something is discovered in one place, then investigations are going to be made in other places. And so, can you just go back? And so, where we intervene, our key role here is the condition assessment, the risk analysis, and helping the operator with condition-based maintenance, how to develop further the maintenance plan. The key goal is what is, well, it's small in the right corner, but that's going from systemic to conditional to predictive maintenance. And I'd say predictive maintenance, it exists in the lift industry, for instance. It doesn't entirely exist yet in the nuclear field, but that's where we're trying to get. To do that, what we need is the digitization of asset that enables to have an asset performance management and not just an asset management. It breaks down, we replace. And the digitization of the assessment themselves. When you've got that, you can start to build toward predictive maintenance. And I'd say that's where our clients are working a lot at the moment, and we help them. What we're going to talk about now is AI-enhanced assessment. Because once we have those three boxes on the left, we have a sandbox in which we can start having AI in the assessment itself. The objective is to help you with the standardization of visual inspection, because when two inspectors look at the same defect, they may have a slightly different analysis of the defect or a slightly different perception of the gravity, the depth. It can help also with year-on-year analysis, checking that a crack, for instance, how is it evolving? With picture comparison, we can have a very robust and objectified tool for analysis to check for evolving defects. AI can also be a digital co-pilot for the operator, helping him to locate defect that he would not have seen. It can be an assistant to find a needle in a haystack. We didn't put a picture here, but for those of you that have been in a power plant, that have seen cables going through walls, it can be dozens of cables going through one wall. One task of the inspector can be to check that there is no two cables touching one another, and that there is fire insulation foam between each and every cable. That's very hard to do just by the eye. The AI, on the other end, can analyze a picture, locate points of interest, and then submit those pictures to the inspector to have human analysis of those specific areas. And yeah, a lot more could be done with AI in the future.
Yeah, exactly. And today we'll focus on only two of them, two use cases. First one being SOFIA. So SOFIA is really about assisting the visual inspector on the site. Okay. So a bit of context just on the visual inspection itself. So I started my career as a civil engineer. I did a couple of inspections myself. One thing that always puzzled me at the time was the time we spent on the data collection, the defect collection. So we spent majority, let's say 70% of the time collecting defects, collecting cracks that are quite, I would say, frequent on the type of infrastructure I worked on. That was not in the nuclear field. And this is at the expense of the analysis time. This is at the expense of the action that we could have on the assets. Second pillar, of course, is the recruitment shortage. We have, of course, more demand and less means, and it requires, of course, a bit of time to have a qualified inspector in order to have all the standard needed. Third point, you mentioned that reproducibility and accuracy, of course, specifically the year-to-year analysis is really key, because when we consider defects, there is, of course, the absolute value that is at stake, for sure, but there is also the trend. Of course, we need to see if the width of the crack is evolving really fast, there is something going on, and we need to act fast. If the width is really stable over time, probably we can just control and make sure that it doesn't vary over time. And you mentioned it also about the objectivity. So it's the same with teachers. I do a bit of teaching. Sometimes you can be harsh on the way you rate the asset. That's the same for inspectors. So there is a human variability here, and AI is also here to help with that. So SOFIA project. So it's a 2 years development project, so it's not something as quick as ChatGPT, I would say, because it requires, of course, a lot of validation and making sure it fits the process. What is interesting to mention, as always with innovation, it's not you and yourself. It's also about making sure you've got the right partners. We decided to partner with the best vision lab in Plateau of Saclay, Cerealist, that is also a nuclear company, by the way. And the position also we wanted to have is really an assistance. Okay, so the target is really about making sure people have the assistance needed in order to take the right decision. So it's about augmenting the human expertise rather than replacing it. You see that, of course, in a lot of media, laying off of people due to AI. This is not the target. This is not the path we choose, of course. And the strategic value we try to have on the business, but of course, we try to address the core challenges I mentioned before. And this is also one of the few innovations on the visual inspection after the introduction of the camera, I would say. So yeah, this is the process of SOFIA. So you're on site. First of all, you mentioned that, Alexander, and it's really key. SOFIA has been developed in the bridge industry. Okay, why so? Because we are more mature in the bridge industry, and we are more willing to innovate in this industry, due to the fact that, of course, there are less validation needed, and we had, of course, a huge database that was needed for this use case. The first step on site, it's really about working the way the inspector is working. So there is no change of process. And I think this is key also in innovation, because when you put a new tool on a process, it's a one change. But when you change the entire process, the adoption, of course, will be harder. So what we choose here is we don't change the process. Operate the way you do. You take your picture. Automatically, it will trigger a first model that is called classification model that will automatically detect the defect, and the bridge elements could be adapted, of course, to other type of element. Then there is a second stage that is a segmentation, where here the idea is to have the quantification of the defects. That is really key, I would say. The third step is about, at the stage or at the scale of the defect, being able to have a severity assessment. So what the gravity index from a scale to 0 to 6, and what is the action that should be done. And then imagine that you have 50 defects on your elements. There is also a proposal at the scale of the component, or in that case it could be the bridge, that proposes you the final assessment, and it's only, of course, a proposal. So now we'll zoom into every stage in terms of technical elements. First, the classification. Okay. classification, what we have here, it's classification models. For those who are not familiar with that type of models, it's really easy, I would say. You have an image, and you attach to that what we call a label. In that case, it's either a default or a bridge element. We've got 13, so this is a perfect number. I don't know, this is pure hazardous. 13 defects that we're able to catch. Among them, crack corrosion, exposed reinforcement, spalling, dripping, stagnant water. So there are plenty of that. This is really scalable to different industries. We already scaled this technology, this backbone technology, to other industries, the defense industry. We are not able to disclose the project, but it's closest to the nuclear field. And then, of course, the bridge element as well, guard rail, all the elements that allows you to attach the default to a component, and then allows you to, of course, structure your data. There is a change in the agenda, so we'll be quick. On that, I think something to mention. We are there to provide trust as Socotec, and of course, the nuclear industry, it's about making sure you have valid process at place. So what we wanted is to have a peer review approach here. So we publish scientific papers in different, of course, conferences and journals in order to cross-validate our approach and the methodology. And we achieve on the market, I would say, a good precision of 80%, could improve and will improve over time. Of course, there is a segmentation after that, where we'll have here, this is probably where the inspector sees the value, to be honest. Because the first one, of course, on an image, I can see the crack. Yeah, that's true. Here, the idea is about quantification, so having the widths directly with the image, and making sure that we achieve this metric, which is a consistency. If I take one image and have several inspectors, okay, please measure the crack widths. What we want to achieve and what we achieved is 95% consistency over time on the measurements, so which is really, really, really great in terms of the objective we wanted to achieve. Last part is about the AI assisted rating system. Here, the idea is, rating the condition of the equipment. We choose something interesting, I would say, to mention, is we choose, from a technological standpoint, simple algorithms that are explainable, specifically for the last figures, the last rating at the global scale. So we choose what we call decision tree, which is not new, I would say, on the market, but allows us to understand the rating for the inspector and then allows him to take the right decision, him or her, I would say. Some figures that probably will skip due to time. And then we'll directly jump into the robots topic.
Maybe we'll skip the robot and go back 2 slides back.
Okay, don't want. Okay, the robot will do the demo on the stand because there was probably a misunderstanding on the time slot. Sorry for that. So we'll be shorter on the presentation. We can do a demo of the robot in our booth that is just over there for those who are interested about it. So we'll finish with SOFIA, if it's okay for you. SOFIA, just 3 key elements that make the project working. Unique database. Data, it's all about machine learning. It's about the quantity of data you have. We are working on a field, it's nuclear infrastructure, that is not the big data world. We are working on the smart data world because the value of the data is there. One rate equals to years of experience of the inspector. It's not, a click position on a screen. Second pillar, state-of-the-art deep learning models. Of course, with huge data, you can have the latest version of algorithm. What we use here is what we call transformer architecture. That is the one that is behind ChatGPT. This is only possible because we got a huge database available. And we cross-check on an international challenge where we took the first 2 positions of the challenge. And the last, of course, are prices, but probably not important to mention.
So we had planned for a 50-minute talk, and we were just told that it's actually 25 minutes talk and 25 minutes in the room if you have more questions.
Oh, yeah.
So we have a lot more to say. So if you're interested, you can meet us in the workshop room just behind the curtain, whatever, and we'll be happy to talk to you about this robot that you've been teased with, but we've not talked about. And I'll just let you conclude the talk.
Maybe as we'll skip one entire use cases, and sorry for that misunderstanding on the planning of this session. I would say 4 key takeaways for you guys if we don't have the opportunity to discuss together. First, AI-driven inspection and predictive maintenance are there for performance of the assets. So we have to be in the performance world, including for the nuclear asset. Second, it's about AI and robotic, as Alexandre showed us. It's really about transforming the entire value chain from the inspection to the maintenance plan, all the parts that we skipped. And the third, of course, you know that we are talking about nuclear asset, infrastructure asset, but data is also an asset. So we should care about data, make sure that those data are structured in the right way in order to, in the future, being able to train AI model on top of that. And the last comment, it's more an opening note. I would say this is only the beginning of this journey. It's a long-term journey. So as always in innovation, we try to be too optimistic short-term, but pessimistic long-term. That's the same applies for robotics and AI in the field. So we think at Socotec that having a long-term approach on our AI development and our robotic development will amplify our human expertise and making sure that we build a safer and smarter nuclear industry. Thank you very much, and sorry for this too short session.